first day of robotics and I'm already confused.
Me too. Hey, there's Robot Inspector. Let's go check it out.
Yeah, that sounds interesting.
Thanks for coming. We are Team Qubit 23642 in San Jose, California.
So tell us, what is robot inspection?
Well, there are four main components that you need to consider when preparing your robot. Robot dimensions, robot signs, safety rules, and testing the robot.
Let's start with number 1, dimensions. You need to consider the size of your robot. The robot must be able to fit within an 18 by 18 by 18 inch cube in its starting configuration. That means the robot can be off or initialized. This is important because the size of your robot is generally not something you can change last minute. However, after the match starts, it can extend. The sizing rule does not count preloaded game elements. Additionally, there is some leeway with flexible materials. Your robot can extend past the 18 by 18 rule, but only with flexible material. This includes things like surgical tubing, zip ties, or string. However, this can only extend to 0.25 inches extra.
Whoa, that's a lot of space.
We're definitely going to keep this rule in mind while we're building our robot this year.
This year, we also have a new rule. In past years, the robot was allowed to extend to any horizontal length and width as it pleased, but there are now restrictions on how far robot parts can extend from its pre-game configuration. There is no vertical height limit, but there is a horizontal limit. As you can see here, the examples on the left-hand side adhere to the guidelines, while the right side doesn't. The robot must fit in a 20-inch by 42-inch rectangle and cannot extend beyond that. The robot can be extended in any direction as long as it fits in the 20 by 42 limitation. Examples A robot is within the area tile footprint, while in example E, the extended robot part is not confined to the area tile footprint. In example B, the robot is completely inside the overall working footprint, while robot F is not. In example C, the robot extends to just the right amount for inside the overall working footprint. In example G, the robot parts extend over the working footprint, and in example D, the robot fits well inside the overall working footprint, while in example H, the robot is tilted in such a way that it isn't properly inside the working footprint.
Interesting. We'll really have to measure our robot's arm length this year.
Now, let's go over some safety rules. Here are some safety rules that you should follow to ensure that you have the best robotic season possible. Refrain from damaging the tile floor. This means you should avoid using sharp materials that could potentially damage the tile floor when it gets in contact. The materials that are considered illegal in FTC are shields, curtains, speakers, sirens, air horns, devices that limit the remote sensing capabilities of other robots, flammable gases, liquid mercury, animal-based materials, and a device that can damage other robots.
Additionally, traction devices, which are parts of the robot that apply force on the field, should not damage the field. High traction wheels, such as AndyMark AM2256, have been found to damage the floor. High grip tread, such as AndyMark AM3309, also have deteriorating effects. Components like these are not illegal, however, they should not come into contact with the field at any time. Furthermore, sharp edges, such as those found on metal parts, should not be able to damage the field. They should be covered in most cases so they don't come into contact with scoring elements or people.
Another new rule introduced in this year's game is of the robot signs. In previous years, the robot had two separate signs of the robot, the alliance marker and the team number. However, this year both the alliance marker and the team number have been combined into one sign on the robot. Additionally, there must be two robot signs on each side of the robot. The dimensions for the robot sign must be at least 6.5 inches wide and 2.5 inches tall. Make sure your robot signs are made of a sturdy, durable material. Examples of material that can be used are wood, metal, acrylic, and laminated paper. However, the robot signs can be made of any durable material and isn't limited to these four items. Here's a diagram of the robot sign sizing.
Oh, that makes sense. But what are alliance markers and robot numbers for? And what requirements do we need for them?
Well, during qualifiers, your team will be aligned with another FTC team. There are two alliance teams, the red team and the blue team. The alliance markers show the judges what side you're on. Since you'll always be on a different color team, you're best to have a red alliance marker and a blue alliance marker. The alliance markers must have a red or blue pig background. Markings excluding the first logo are prohibited. This is how our alliance marker should look like. As for the robot numbers, they should be in white letters, 2 inches tall, and not vertically stacked. In addition, there should be 1 1/4 inch background around the letters.
So, can I use any parts to make my robot?
Good question. This year, they introduced a new rule about commercial off-the-shelf items, or COTS. To be considered a COTS item, it must be a product that can be available for all teams to buy. This means it cannot be a custom product or only provided locally. Legal COTS products can be modified though. This makes it a fabricated item. You can also make fabricated items from raw materials such as sheet stock, extruded shapes, metals, plastic, rubber, wood, or magnets. COTS items can only have a single degree of mechanical freedom. This means that your specific mechanism can only turn or move in one way. The mechanisms that cannot have multiple degrees of freedom include linear slides, which can only move vertically or horizontally, but not both. Pulleys, which can only rotate in one plane, or turntables, etc. Exceptions to this rule are mechanism wheels, holonomic wheels, and dead wheel odometry. As you can see, the exceptions are generally wheels. This is because these wheels have rollers on them. The mechanism wheel rollers allows them to strafe or move to the side while facing forward. Although this can be considered 2 degrees of freedom for the wheel itself, it is not illegal.
Can you give us some examples of what is allowed and what is not?
Sure. Here are some scenarios from the game manual. Our first scenario is a team orders 2 robot panels from RoboPanels Corp. and receives both items. They put one in their storeroom and plan to use it later. Into the other, they drill lightning holes to reduce weight. The first panel is still classified as a COTS item, but the second panel is now a fabricated item as it has been modified. Another scenario is a team obtains openly available blueprints of a drive module commonly available from Wheels R Us Inc. and has local machine shop We Make It Inc. manufacture a copy of the part for them. The produced part is not a COTS item because it is not commonly carried as part of the standard stock of We Make It Inc. Another scenario is a team obtains openly available design drawings from a professional publication and uses them to fabricate a gearbox for their robot. The design drawings are considered a COTS item.
What about actually getting the robot to work? Is there a button?
Actually, yes. It's called a power switch. The power switch must be connected to the battery and should be easily accessible to field staff at any time. There are only 3 types of power switches allowed: Andy Mark FTC power switch with a bracket, Rev switch cable and bracket, and the Tetrix RC switch kit. Just a side note, there are no specific location requirements for the power switch, but it is recommended to steer clear of any moving parts or obstacles that would block the switch during routine robot movements.
Are there any requirements for labeling the power switch? Are labels even required?
There is a very important rule regarding the labeling, and yes, it's required. The power switch label must be placed on the switch and should measure 1 inch by 2.5 inches. This is an example of a power switch and what a label may look like for your team.
You will need a battery, and there are certain restrictions on which batteries are allowed in the competition. For the robot, the only allowed battery is a 12-volt NiMH battery from certain companies. These companies are Andy Mark, GoBuilda, Rev, Matrix, Studica, and Tetrix Max, which as you can see in the chart above. A tip for your robot's battery is to always check that the battery is properly connected. If not, the battery could disconnect on the field, which we experienced last season. When the battery disconnects, the robot stops moving completely and there is nothing you can do about it. So really watch out for how securely you attach the battery to the robot. Other tips are to charge batteries before qualifiers and to bring extra ones as backup if you can. Additionally, keep in mind that the robot's speed will differ based on the amount of battery power.
So how does a robot connect to the controllers?
That is the power of Wi-Fi. Before we begin, however, make sure that your Rev Control Hub is renamed to your team number -RC. For example, for Qubit, it would be 23642 -R C with no spaces in between. The driver station must also be renamed to the team number -DS. In Qubit's case, it would be 23642 D C with no spaces. Another tip is to update your driver station regularly. In order to do this, you can select the About menu on the app and then check the app version number. The Rev hardware client software will allow you to download the following apps to approved devices: the Rev Control Hub, Rev Expansion Hub, Rev Driver Hub, and approved Android devices.
Some benefits include connecting a Rev Control Hub via Wi-Fi, a one-click update of all software on connected devices, pre-downloaded software updates without a connected device, backup and restoration of user data from Control Hub, installation and switch between DS and RC applications on Android devices, and access to the robot control console on the Control Hub. Before the day of the competition, remember to rename your Wi-Fi. You can do this by clicking Manage on the Control Hub and renaming the Wi-Fi and password.
You will be asked to test your Teleop and Autonomous for approximately 1 second during inspection. Your robot will be tested for if it can stop on command.
What else do I need to know to do well in robot inspection? Are there any general suggestions that would be helpful?
A few tips for success during robot inspection is to get to inspection early. This way, you will get more time to use your robot on the practice field and can reserve better times for the field. Additionally, before you head to robot inspection, make sure your Wi-Fi is named properly, your battery is fully charged, and you have all the correct alliance markers. Doing this will prevent any delays and ensure that you have a smooth competition experience. Always bring extra screws, motors, tape, servos, or anything else your robot may need. This way, you can resolve any issues your robot has quickly and efficiently. Also, double check your robot and fuel inspection checklist before competitions to make sure you have fulfilled all the requirements. You don't want a disqualified robot because you went over the 18-inch limit.
We hope your robot inspection goes well this season.
Thank you for listening to our presentation.